Good morning to all of you. So today we are going to start a new topic after the polar coordinates, and that new topic is a very well-known topic for you, and that is Newton's laws of motion. Now you may think that why again Newton's laws? Because you have been studying Newton's laws since your childhood or your boyhood, maybe standard 7 or 8. From that time onwards you have studied Newton's laws. But what happens that the level of study differs. You studied in schools in one particular way, then you went to the colleges, then you studied another way. Here we are going to study little more, that is mostly on polar coordinates. And there will be one lecture basically on polar coordinates. But the first two lectures, I will be giving 3 lectures. The first 2 lectures will be completely basic. Because what I found that when the students come here and we give them questions, they make a lot of silly questions, silly mistakes. And these basic things, they make mistakes in these basic things. So that is why this time, this particular year, I thought of making 2 more lectures totally on basics. Alright? Okay, so today the first lecture we will be on purely on basics of Newton's laws. The second lecture will be on centripetal force and centrifugal forces. Alright? And the third one will be on Newton's laws on polar coordinates. Okay, so let us begin. Newton's laws. First, basic fundamentals, significance of the first law, action-reaction pair. Then we will see free body diagram, very important. Equations of motion, these 2 are very important. The examples I will take: rectilinear motion, inertial frame and non-inertial frame. Then lastly, few words about friction. Okay. Now, so first law, second law and the third law, the 3 basic laws of classical physics. Very one of the most important laws of classical physics. Okay, so the first law you have studied well. Let us come to the second law. I want to ask you one question here. What is the significance of the first law? In the second law, let us come to the second law. Now, the second law gives you the mathematical formulation of force. F is equal to dp by dt, ddt of mv. Now, we define, the Newton's laws are defined for constant mass. M I can take out, m dv by dt is equal to ma. Now, the question is, if A is equal to 0, F is equal to 0. A is equal to 0, F is equal to 0. Then V is equal to constant. So, my question to you is that this is exactly what the first law says. A body will continue to be in its state of rest or of uniform motion in a straight line unless acted on by a force. So, if the force is 0, acceleration is 0, velocity is constant. This is Newton's first law. So what we find that the first law is coming from the second law. Then what is the significance of the first law? This is a very popular question, often asked. So I thought that let us revise this concept so that each one of you should know this. So what is the significance of the first law then? Any answer? See, I will give you an example. The example is, suppose I am traveling in a train and the train is accelerating. Now, if the train is accelerating, from an accelerating train, I see a person standing on the platform. I see that person going backward with an acceleration A. Now, a standing person from an inertial frame, he observes that the person on the platform there is no force acting on him. So, if no force is acting on him, how can he have an acceleration? How can he has an acceleration? So, that is where the whole problem is. Newton's first law is that if acceleration is equal to 0, force is equal to 0. Alright? Now, if you find this in a particular frame, that means in all the frames, like if I am in an accelerating frame, I am seeing him accelerated, whereas no force is acting on him. So, if force is 0 and acceleration is 0, in a particular frame, then that frame is known as inertial frame of reference. So, the Newton's first law, whatever it says, that a body continues to be in its state of rest or of uniform motion in a straight line unless acted by a force, this will happen only in a inertial frame of reference. So, the significance of the first law is it defines the inertial frame of reference. It defines the inertial frame of, defines the inertial frame of reference. Inertial frame. I hope this is very clear to you. If the force is 0, acceleration is 0. It doesn't happen everywhere. It will not happen from a non-inertial frame. Only in an inertial frame that will happen. So, the Newton's first law defines the inertial frame of reference. In non-inertial frame, that will not happen. Now, any frame which is moving with respect to the inertial frame at a constant velocity is also an inertial frame, or if the frame is at rest, obviously. Now, whenever we talk about inertial frame, there is another concept that usually comes, and people often ask this. So, another question comes here, is Earth a inertial frame? Is Earth an inertial frame? Now, this is again a very important question. Is Earth an inertial frame? Now, as you see, the Earth is rotating, alright? Rotating about its axis. It is also rotating about the Sun. The Sun is rotating about a particular point in a galaxy, alright? So, the whole Sun, Moon and Earth is rotating basically. So, is Earth a inertial system? Yes. For all practical purposes, when we study Newton's laws, for all practical purposes, we take Earth as a inertial frame of reference. And why we take it? Why? Because it is rotating still. Why we are taking it? Because this rotation or the spinning of the Earth, because of which we are having day and night, if you calculate this centripetal acceleration, that means it is rotating, any particle will have a centripetal acceleration because of its rotation about its axis. So that is minus omega square r. Okay. Now omega square you can calculate 2 pi by t whole square. Now time period 24 hours. Alright? 24 hours. Now if you change it into seconds and then if you calculate omega square r, you will find, all these things I have given in the notes, you can refer back. So what you will find that the centripetal acceleration is 300 times smaller than the gravity, g. That is why we can neglect it. And if you think the rotation of the Earth around the Sun, it is still smaller. If you consider the rotation of the Sun and its system around a point in the galaxy, it is still smaller. So those things are neglected. But even this spinning is much smaller compared to g. And that is why for all practical purposes we can neglect that and we consider Earth as an inertial frame of reference. Now, when we study the non-inertial chapter, in that chapter we will learn about Earth as a non-inertial frame, and we will see there are certain effects in the Earth which describes the movement of the winds and things like that. So Coriolis force and centrifugal force, all those things we basically at that time we will learn. But for now, at this point, we consider for all practical purposes, we consider Earth as a inertial frame of reference. But strictly speaking, it is not. Now, once the first law defines the inertial frame of reference, then other laws are valid in an inertial frame. Like second law is valid in an inertial frame, third law is also valid in an inertial frame. If the frame is not inertial, the action-reaction pair will not be exactly the same. So basically the first law defines the inertial frame and other law basically states about the force and the action-reaction pair. So I hope this is clear to you. This is a very important concept. Often this question is asked that what is the significance of the first law? First law defines the inertial frame of reference, and then the other laws are hold good in that inertial frame of reference. Second law is okay. Third law. Now third law talks about action-reaction pair. Here we are talking about only one body. Alright? One body and that is all. Here basically we are talking of two bodies. Force always occurs in action-reaction kind of thing. But here it is more clear. Okay. So here there is again a popular question. And what is that popular question? Often it is asked. So you should know that. The question is that there is a horse and there is a cart. So the horse is pulling the cart. Now the horse is pulling the cart by force F. According to Newton's third law of motion, the cart is pulling the horse with a force F. Okay. So if the action-reaction pair, they are equal and opposite, they are of the same magnitude, then the net force will be 0. If the net force is 0, then how the horse moves the cart? So that is a question. Often this is asked. I hope all of you know this answer. The answer is that action-reaction pair, they do not act on the same body, but they act on different bodies. So that is why if we take this body, it is this force which is acting. If you take this body, it is this force which is acting on it. So basically, because of this force, the forward force onto the cart is moving. So action-reaction pair, they do not act on the same body, but act on different bodies. Now, there is another next question, that then why the horse is not coming backward with an acceleration? Because there is a force F. Now, that are also, I hope you know this answer. This horse pushes the ground by a force and gets a reaction force because of the reaction of the earth as well as the friction. So there is a forward force the horse gets, and forward force minus this backward force which is applied by the cart gives the acceleration of the horse. So that is an answer. So I hope this is clear to you, and this is a very popular question, and I think most of you know this answer. Okay. Now let me come to the next topic, because it is for this topic, mainly for this topic, I have planned this lecture. Because what I find that in the exams, when I say write the free body diagram, write the equations of motion, a large number of students, in spite of they have done so many problems in their class 12, class 11, in their coaching centers, still they are unable to write it. So that is why I have specifically written these two terms or these two topics, that is free body diagram and equations of motion. Now let us see what are they. You know very well. You know all these things. but these terms confuse you. So, free body diagram, FBD, what does it mean? It means that if there is a body, you have to show all the external forces acting on the body. And like suppose I have taken an example. The example is there is a block, okay, of larger block, mass m, which is an inclined plane, and in that plane there is a smaller block of mass m which is sliding. Now with an acceleration a. What I am supposed to do, I have to write the free body diagram of this mass m, smaller mass m. Now, in Newton's laws, we consider bodies as a point mass. But I have not taken as a point mass, just sometimes it is easier for us to see where the forces are acting and calculating the angles also. But I will be doing that as well here. So let us see, you know very well the force of gravity, mg, the normal reaction by the surface onto the block, and if the block is sliding, if this surface is having friction, then there is a frictional force opposing the motion. So these are the three forces which are acting on the particular body. So you can write it like this way. The best way of writing it is by a point mass. Here is your mg, and here is your normal reaction N, and here is your frictional force Fk. This is the most correct way of drawing a free body diagram, by making a point mass. In Newton's laws, even the planets are considered as point. Alright? So no rotation or anything of that kind. It is taken as point mass. So you have shown all the forces. That completes the free body diagram. That's all. You don't have to do anything. Free body diagram is this. Or you can do this also. Now, again I find confusion in this term, equations of motion. What is equation of motion? The Newton's laws, F is equal to ma, that you have to resolve it. You can write that also. You have to resolve along x and y direction. So sigma fx is equal to max. That means algebraic sum of plus minus whatever of all the forces along the x direction, that is m times ax. Sigma fy, resolve all the forces and add them in the y direction. Algebraic sum fy is equal to may. Now you should always write these two formulas. Now here, as you can see, you can calculate the value of ax and ay, and from there you can calculate the value of a. Also, suppose say if you want to calculate the velocity, you can write in place of ax dv by dt. Okay, dvx by dt, dvy by dt. So that will give you the expression of velocity as a function of time. So that is also you can calculate basically velocity as well as you can calculate acceleration, and that is why these are known as equations of motion. So whenever if you are asked equations of motion, these things that you have to do. Now obviously the question you will get, or you usually get in your exam, is on r theta. So there instead of x, y, it will be your r and theta. Okay, so that is the whole thing, that is the whole change that you have to do, equations of motion in r theta. I hope it is very clear to you. Now these things you have done too much, lot of problems you have solved. Along the x direction, this you have to choose. You have to choose the axis. So I have chosen x and y. Then along the x, you resolve all the forces along the x. So mg sine theta minus fk, that is the net force, alright, along the x direction, is equal to m into ax. Here along the y direction, it is along the y direction, mg cos theta minus n. Mg cos theta minus n is equal to MAY, which is equal to 0. So, that completes these two equations, that is your x direction and y direction. So this is actually your equations of motion. I hope you know now these terminologies and things are clear to you. Okay, now let us come to an example. So I would like to show you just one example. The example is, this is very well-known example, and I think you know you have done it many times. There is a block, larger block of mass m, and on the side, just touching this block, another small block of small mass m. A force is applied here. There is a force which is applied here. A force is applied. What will be the acceleration? Simple problem. Now, here what we do, this is a very important concept, when we try to solve some problem, what we have to do is, we have to choose a system. What is the system here? Because here both the bodies are moving with the same acceleration. So this is a system that we choose, alright? This is a system. This is our system. I treat this as a whole. Okay, so let me write, this is my system. Okay, now once I have chosen the system, I have written the forces acting on it. So this is only one force F. There is no internal force. I have to calculate the acceleration as well as the contact force, that we will do it later. So sigma Fx is equal to max. F is equal to m is m plus m, that is my system mass, into A. So A is F divided by m plus m. It is as simple as that. The concept that I would like to focus on is choosing the right system. That is very important. And then you choose the axis. Now, if I need to calculate the contact force, so let us see how to calculate that. Then I will write separately for each body, free body diagram of each body. So this is, I have separated the two bodies. Obviously, this body is giving a force onto the smaller one, and the smaller one is also giving a reaction force onto the larger block. So now I write all the forces acting on this body. So now my system is, this is my system. This is my system. This is my one system, this is my another system. So in this system, what are the forces? The force F, which is applied, the reaction force F, the normal reaction N, and the force of gravity mg. These are the forces. Now if you draw it using a point mass, that is better. Otherwise, this is also okay. Here also, as you see, the force of gravity, the normal reaction, and this F. Now I will write, because there is no acceleration along the vertical direction, along the y direction, sigma Fx is equal to max for each one of them. So I write that F minus F is equal to ma, F minus F is equal to ma, because only in this direction, this I am not taking in, because obviously there is no acceleration along this direction. I have to find out the F, and here F is equal to ma. So directly one can calculate the value of F from there. So the first thing, the most important thing that we learned here is choosing the right system and then show the forces acting on it. Second thing, from this particular example, if I apply the same force on this side, from this side, what will be the F? Will it be the same or will it be different? I would like you to calculate that. Will it be the same F or will it be different contact force if I apply the same force from this side? Good. So then we will take the second example. Okay, now let us take another example, example 2. Here, this example shows how to solve problems in a non-inertial frame of reference. Inertial frame we have seen. In a non-inertial frame, if a frame is accelerating and an observer is there in a non-inertial frame, then from non-inertial frame he is observing something. So, whatever he is observing, that event may be in the non-inertial frame or in the away from the non-inertial frame. Like as I told you, a train is accelerating. I am there in the train, that is non-inertial frame. I see a person standing in the platform. He is going backward. So basically I have to give a force, negative force. Alright? M into M of that person multiplied by the acceleration of my frame. So it is a frame actually. It is a frame dependent force. Whether the event or of the thing that I am observing, it may be within the frame or outside the frame. Okay. So here, what we find that there is a small block of mass small m sliding over a wedge whose mass is capital M. Now, everything is frictionless. When this block is falling, it is giving a force, pushing, and because of that force, the whole system moves to the right. Okay. We have to find out this acceleration a0, and this block is falling onto this wedge with an acceleration a. We have to find out the value of a also. So how to do it? Now you can solve it using your inertial frame of reference, or you can solve it using non-inertial frame of reference. Now, sometimes it is easier, convenient, it looks good. So we have chosen non-inertial frame of reference. Here what we find, since this block is falling onto this surface and this is moving, and it is asked what is the acceleration a with respect to this wedge. Since the wedge is moving with respect to this wedge, so it is easier, better, looks good if I can solve it using a non-inertial frame. So here this wedge is moving with an acceleration a, and in that wedge, from that wedge basically, I have to see the acceleration of this one with respect to this wedge, accelerating wedge. So this is a non-inertial frame. It is an accelerating frame, it is a non-inertial frame. And in that frame, this body is falling. Now, if you want to work with Newton's laws in a non-inertial frame, you have to act as pseudo force. And that is what I have shown by red. Pseudo force, how much? Mass multiplied by acceleration of the frame opposite to the acceleration of the frame in which it is, from which we are observing. So basically, MA0 opposite to A0. MA0. So this is the direction of the pseudo force. Now, this thing you have to write it. That you have chosen a non-inertial frame, and from that frame you are solving this problem, and this is a pseudo force. This you have to write it in words. Only then, the examiner will see that yes, you have solved it from a non-inertial frame. So now you choose an axis, x and y I have chosen like this. So sigma fx is equal to max. All the real forces are there. That is your mgn that was there, even if it is at rest, in an inertial frame also these forces are there. So you resolve these forces, mg sine theta along the x direction plus ma0 cos theta is equal to max. So ma, alright, this is small m, all small m. Then sigma fy in the y direction, there is no acceleration with respect to this frame. So again I write mg cos theta minus n minus n minus m a0 sine theta minus m a0 sine theta, that is equal to 0, because there is no acceleration along the vertical direction. Now what you see, that these two equations are there. We have to find a0a, but n also we don't know. So we have 3 unknowns and 2 equations. We have to get one more equation. That is what I have written here. Okay, how to get the third equation? There are different ways of doing it. Sometimes one can find it using a geometry, but here I am just taken the problem from H.C. Verma and the way he has solved also. So let us take the larger block. All right. Now from the smaller one we come to the larger one. The larger one is accelerating. So I observe this block from an inertial frame, which is actually fixed to the earth. The real forces, the force of gravity, the normal reaction, n prime, and the normal reaction, this particular surface was giving a normal reaction to this. So by reaction it will get n over here. This n is basically, this smaller block is giving onto the larger block. So this is FBD in inertial frame of earth. Okay. Now sigma fx is equal to max. Sigma fx is max. So that is n sine theta is equal to, that is the only force in the x direction, is equal to ma0. We can write one more equation, that is mg minus n prime, then minus plus n cos theta. We can write that, but it is not necessary, because we have to find one more equation, and from there we have to find out the n. So from here we find n is equal to ma0 by sine theta. If we substitute there in those equations, we get a0 and a. This is the value of these two quantities. So you have done, this is a very, very important problem, and this is a example how you can solve problems in non-inertial frames. Now you must have seen there are different problems, like the problem of a pendulum when the train is accelerating. That is also one problem, very common problem of a non-inertial frame, the pendulum in a train. You have also solved a person going up in an accelerating lift, down in an accelerating lift. So all these problems you can solve it using non-inertial frame of reference. Good. So let us now see let us now read some very few basic facts which you know very well from friction. All right. In friction, again, when people ask questions, there are a lot of questions from these two topics. One topic is the direction of friction, and other is the coefficient of static friction. Okay? Now, the direction of friction, suppose there is a person. This is not a person though, I could not draw, but anyway. So a person is walking. What is the direction of friction acting in his or her foot? All right. So, or in the sole of the foot, you can say. So, the way we can see is that here usually our concept is that when something is moving, friction is acting in the opposite direction, but not always, like this case. When a man moves, so what he is doing, he is basically pushing the earth in the backward direction, and also the normal reaction. So the frictional force basically gives a force, the friction force gives a force in the forward direction, and because of that a man moves. Alright. So that is what I have shown, that the frictional force is actually in the forward direction in the sole of the feet or in the shoes when a person is going forward. And that helps the person to move. Second example is that of a bicycle. And here, when somebody is paddling, alright, so what he is doing, he is giving a pressure. basically force, opposite force, and from the earth he is getting a backward, forward push. So that is basically the friction at the back tires is in the forward direction. In the front wheel, basically the front wheel is moving now. So in the front wheel it is in the backward direction, but in the back wheel it is in the forward direction, mind it, when he is paddling. When he is not paddling, both the friction should be in the opposite direction, in the tires of the wheel, at this end, where it is touching the ground. So this is important. Exactly similar way, when a car is moving, the rear wheels and the front wheels. In the rear wheels, when there is an accelerator, when a driver pushes the accelerator, so there is an trying to accelerate, he is giving a force backward, and the friction in the rear wheel basically is in the forward direction. Exactly in the front tires, basically, the front tires, the friction is in the backward direction. So I hope these are the examples which you have read and all of you know about it. Okay. Now, let me, a lot of questions I think till now I have seen in IIT JEE papers also are asked on this particular concept. That is the concept of static friction. So let me tell you what is the problem is about. That here there is a block of mass capital M. This is not a block, this is a duster. Alright? The board and the duster. So this is a duster. And a man gives a force F onto the duster. So if I draw the free body diagram as a point mass, because here that is easier, so I have drawn that point mass. So this is the force he is giving, this is the force. Now this blackboard is giving a normal reaction. The blackboard is giving a normal reaction N. Okay. Now the blackboard and the duster, the duster is not falling. So it is, he is giving a force and he is holding on to the duster. In this direction, there is no acceleration. Obviously, F is equal to M. That is what we have done. Sigma Fx is equal to Max is equal to 0. So net force actually is 0 because acceleration is 0. So F is equal to M. Okay. Now, in the vertical direction, what are the forces? There is a force of friction upward because it is trying to move downward. So obviously the force of friction is upward and the force of gravity is working downward. Okay, this is the force of gravity. Since there is no acceleration in the vertical direction, mg minus fs is equal to 0. mg minus fs is equal to 0. Fs is your static friction, which is equal to mu s times n. Okay, because mu r, so r here is n. This is n, so mu s times n. Now this is the statement. Now question is that he was giving this force. Suppose now the force, whatever he is giving, pushing, that force increases. He is increasing the push. The moment he increases the push, this normal reaction will increase. The moment he increases the push, the normal reaction will increase. That is, from the board to the duster. Now, if the normal reaction increases, the force of friction, static friction, is mu s into n. So, if n increases, Fs will also increase, isn't it? So, if F increases, n also increases, Fs also increases, because Fs is equal to mu s into n. Then, why duster does not go up? So, as you see, Fs has increased, mg is constant, so it should go up, but it is not going. What is the reason? I hope the question is clear to you. So, the duster should go up because Fs is increasing. Because Fs is mu s into n is increasing because F has increased. So, the duster should go up. So, this question was asked basically in the comprehensive examination, and I would like to write the answer also. So, what is the reason? The reason is, whatever I said, it is not true. Here actually the reason lies. When n increases, mu s is not constant. Mu s is not constant. The coefficient of static friction varies from a minimum value, 0 maybe, 0 to some maximum value. Alright? So, the coefficient of static friction varies. So, as n is increases, Fs will decrease, and that is why, mu s will decrease and Fs will remain constant, and that is why this is not falling, because the force of friction is equal to the force of gravity, they balance each other. So, this is the reason. So, lot of questions you will find. So, it is the answer I would like to write is the mu s is variable. Mu s, coefficient of static friction, is variable from a, it varies from 0 to some maximum value, whatever it is, and that is the answer, and that is why it is not falling. So that is all about it. So these are the points what I felt that one should know about the Newton's laws. The basic things which you have done maybe many times, and I just listed them, thought about it, what the students make mistakes, and I have written all those facts and things in this particular lecture. Small lecture, but should be, you should refresh your fundamentals. The most important thing is that the term free body diagram. What is free body diagram? All the external forces you have to show. And second concept is equations of motion. So these are the two things basically is very, very important, and you should know, you should write down the equations. You should always write sigma fx is equal to max, sigma fy is equal to may. That way you will never make mistakes. Alright? You should always write that equations. Sigma fx is equal to max, sigma fy is equal to may. Other things I hope you know, but those are the two places I found that a lot of students they make mistakes because they are not familiar with the terms. Alright. So this is all about it today, and in our next class, next lecture, we will study about the centripetal and centrifugal forces, because a lot of students I found they have confusion regarding these two forces. That's all for today. Thank you very much.